Okay, today we're doing Unit 5, the Probability Escape Room. Normally we would do this in a Google form, however, I thought the slides would be a little bit more exciting. So due to the virus pandemic, the country is in disarray. The mayor of your city is issuing a 2-week citywide lockdown. Dun dun dun. That means that you will not be able to leave your house for 14 days, and you only have one roll of toilet paper. Can you find enough toilet paper and other supplies to make it through the quarantine before the lockdown order takes effect? Hurry! The store shelves are almost bare. See? Your one roll of toilet paper is right here, and you've been using it. So now we need to stock up. Oops, we only had the one. All right, so we're headed to the corner store. They usually have some extra TP in stock, so we're going to answer the questions on the next slide correctly to buy our TP. And we're going to round each answer to the nearest hundredth. All right, so the first thing I want you to do is place a line under the word fraction, circle the word decimal, and place a square around the word percent. That way we know we're getting our answer correct. We're also going to understand what the rule is to convert the fraction to a decimal, or from a decimal to a percent, or from a fraction to a percent. So let's start with number 1. We're underlining our word fraction, we're circling our word decimal, and our rule is we're going to divide the numerator, or the top number, by the denominator. So 24 is divided by 80. My answer then is 0.3. Now, if I was rounding to the 100th percent, or the 100th, I would actually have another 0. So it would be 0.30. So I do apologize for that. I just was going through this quickly, but if you put 0.3, that's fine. So we're going to convert a fraction. We're underlining the word, circling the word decimal, and then we're going to find our rule. We're going to, again, divide the numerator by the denominator. So 3 is divided by 8, and that gets me 0.375. Again, I'm sorry, I did not round, so I didn't even follow that rule. But that's okay if you go ahead and put that in there. That's fine. We're going to circle the word decimal. Now we're going to convert a decimal to a percent. So the 0.49, we need to move that decimal 2 places to the right, and that's going to give us 49%. We're going to convert another decimal to a percent. My decimal is 0.7. My rule is move the decimal 2 places to the right. I go ahead and do that. I have to add a 0 at the end, and it's 70%. The last one is I'm going to convert this fraction to a percent, and the fraction is 2 over 25. So I need to do a couple things. I need to divide the numerator by the denominator. So 2 is divided by 25. I'm going to move the decimal 2 places to the right after I get my answer, my division answer, and that's going to give me 8%. So then I'm going to convert a fraction to a percent, 3 over 75. My rule, I need to divide the numerator by the denominator. 3 is divided by 75. That gives me a decimal. I'm going to move that decimal 2 places to the right, and that's going to give me 4%. So you are now done with this slide. Woohoo! We got some toilet paper. Excellent. So we're on our way. So not only did the corner store have some TP on hand, but we converted all those numbers correctly in order to purchase them. All right. 3 rolls to start, but you're going to need more for your family to make it through 14 days, because that's a lot of days with just 3 rolls of toilet paper. So let's go to the food and pantry store. The volunteers at Food and Pantry are overwhelmed with people who need supplies, so they're handing out items randomly. Look at the supplies at the top right corner of this next slide to answer the questions. Right here are the different supplies that they have. So what is the probability that the volunteer will randomly hand you a roll of toilet paper? Well, first of all, we need to go ahead and see how many items we have. 1 shampoo, we have 5 hand soaps, 2 toothpaste, 2 tissue boxes, we have 4 deodorants, and 6 rolls of toilet paper. So total, I have 20 items that person could randomly grab one and hand it to me. So all of my fractions are going to be over 20. So what's the probability the volunteer is going to randomly hand me a roll of toilet paper? Well, that's 6 rolls of toilet paper, 20 items total, 6 out of 20. I'm going to express my answer as a decimal. Did I do that? I did not do that. let's go back. We're going to express our answer as a fraction. If you do a decimal, that'll be great. I'm sorry. Again, now it's raining outside, so hopefully you can still hear me. It's 3 out of 10. My decimal will be 0.3. Okay, so what's the probability that the volunteer will randomly hand me a bottle of shampoo? I have 1 shampoo out of 20. 1 bottle of shampoo, 20 items total. That's 1 out of 20. That is going to be 1 over 20, or my decimal would be 0. Not 5. Hold on. It would be not 0.1. It would be half of that. Either way, if you put the decimal in there, I can't figure it out right now. And hold on. I have a calculator. Sorry, wasn't prepared. Trying to get a video out. I didn't realize I didn't have one for you guys. So it would be 0.05 as a decimal. What's the probability that the volunteer will randomly hand me a container of soap? I have 5 containers of hand soap, 20 items total. That is 5 out of 20. And that would give me 1/4. 1/4 is 0.25 as a decimal, 0.25. What's the probability that the volunteer will randomly hand me a box of tissues? I have 2 tissues out of 20 items total. So that would be 2 out of 20. If I reduce that, that's 1 out of 10, or 0.1 as my decimal. Cool, look at that. I got some more items in my bathroom. Awesome. I want those. All right, so we're getting there. Nice work. The bathroom's starting to become well stocked for the next 2 weeks, but we're going to need more supplies. So we're going to keep working. We're going to go to the supermarket. It looks as though no one else saw this cart of toilet paper tucked away in the back corner of the supermarket. We have to act fast, or somebody else, anybody else, would notice all this toilet paper. There's all kinds mixed together, regular, quilted, and different plies. So we need to find out what type of toilet paper from this cart we're going to end up getting. Up here, we know we have 25 rolls of toilet paper total. 12 rolls are quilted, 6 rolls of 1-ply, 7 rolls of 2-ply in our cart. Again, it says express your answer as a decimal rounded to the nearest hundredth. Let's actually see if I did that. So I apologize ahead of time if I didn't. So we randomly take 1 roll of toilet paper out of the cart, but then we put it back, and then we take another roll out of the cart. So what's the probability that the first roll is going to be 1-ply and the second roll will be quilted? So because we're taking it out and we're replacing it, our total is going to be the same on the bottom for each one. So I have 1-ply, there's 6 1-ply out of 25 quilted. There are 12 out of 25. So I'm going to take those and I'm going to multiply them together. And that's going to give me 72 out of 625, or, look, I did it, 0.12 as my decimal, because I'm going to divide 72 divided by 6.25. Okay, so now we randomly take out another roll of toilet paper. We're going to put it back, and then we take out a second one. The order we have that in is we're going to take out a 2-ply and then a 1-ply. Because I put it back, my number on the bottom is going to stay the same. My 2-ply is 7 out of 25. 1-ply is 6 out of 25. I'm going to multiply those together, which is going to give me 42 out of 625. I'm going to divide 42 by 625, which is going to give me 0.07. What you're taking away from here is that you're putting the toilet paper back. So this is an independent event. The second event is not dependent on the first event. But to get these events in the order that we're getting it, this is the probability that this order will happen. So now we're going to take our quilted, then put it back and end up with another quilted. That's 12 out of 25. We're going to multiply that, excuse me, 144 out of 625. I'm going to divide 0.23. So this is the probability that this will happen, that I will take that one, put it back, and take that other one. And that's what we're looking for. If we just want the probability of taking that one, we would just have this fraction. But because we're taking that one and then we're seeing what the probability of taking this one after we had taken that one and put it back, that's what this number means. Okay, look at that. We're getting closer. Almost there. All right, so impressive. You earned some more toilet paper. Look at that. Woohoo! Now we don't have to worry. But we still have that quarantine, 14 days. So let's go to the dollar store. And this will be our last stop before we head back home. So now we're going to do an independent or I'm sorry, a dependent probability. We're going to do 3 of them that are dependent, because when we take the first item, that's going to affect what's going to happen with that second item, or the probability of that second item. So we take the first item and we're going to put it in our basket, so we're not putting it back. The first thing we need to do is total up all of our supplies. We have 7 toilet papers, 6 toothpaste, 11 deodorant, 5 soaps, and 4 shampoos, which gives us a total of 33 items. So when I go for this first one, I take a roll of toilet paper out. That's 7 out of 33, but I'm not putting it back. I'm actually putting it in my cart. So then I go for a toothpaste. Notice how my bottom number changed by 1 because I took that toilet paper out. I still had 6 toothpaste though. I'm going to multiply these 2 fractions, and then I'm going to get my answer. And of course, I'm rounding my decimal to the nearest hundredth. So 7 times 6 is 42. 33 times 32 is 1,056. I'm going to divide 42 by 1,056. That gives me 0.04. My second problem, I'm getting a container of soap, which is 5 out of 33. I'm going to get a bottle of shampoo because I didn't put that soap back. I put it in my cart. My shampoo is 4 out of 32. I'm going to multiply those together. That's why my bottom number is different, because I didn't put it back like before I put the toilet paper back. This, I'm not putting my items back. So I'm going to multiply, and then I'm going to divide and get my 0.02. The last one, a stick of deodorant, I take it out. I put it in my cart. I take out another one. Notice how that number changed as well. Then my bottom number changed, my total amount of items. I'm going to go ahead and multiply those, then divide, and I get 0.10. Okay, so this is why these bottom numbers are different. That's why the toilet paper, when I put it back, the bottom number stayed the same. Either way, I'm just multiplying those fractions because I'm looking at this as a whole. What would have happened if I did this whole process? What's the probability of that whole process happening? That's why we're multiplying. All right, look at that. Woohoo! Yeah, we stocked up our bathroom. We are now ready for that quarantine. We did it. We're going to smell really good because we have deodorant. Our teeth are going to be nice and clean because we have toothpaste. If we get the sniffles, we got tissues. But more than anything, we get that toilet paper going on. So that's great stuff. So we're fully stocked. We did everything that we need to do. And we also were able to figure out our probability. You guys are awesome. Thanks so much for playing the escape room with me. And I hope you have a great day.